Hello, everyone. I'm Mostafa Salari, currently a postdoctoral fellow at the University of Calgary, Department of Civil Engineering. Today, I would like to present a part of my research, which was on modeling the effect of sensor failure on the location of counting sensors for origin destination estimation. I did this research under the supervision of Dr. Lena Gatan at the University of Calgary. To begin with, I need to mention many of the studies in the context of sensor location problem. They assume that there is no failure among sensors, or the failure among the traffic sensors is a trivial matters. Although by looking at the practical notebooks, we can find that the failure rates of sensor can sometimes exceed 25% of all sensor deployment. And by looking at more recent studies, we could find that these studies actually stress on importance of considering failure of sensors as an influential factor for sensor installment. One of the concepts I mentioned in my study is OD demand flow information loss. Many studies in this context, they assumed the main source of information loss is the estimation error, which is the error of estimating OD demand information between OD pairs. Although in this study, I assumed that besides the estimation error, the sensor failure also plays a crucial role in losing the OD demand flow information. Based on these considerations, I proposed two factors for sensor deployment in a road network. First one is maximum OD demand flow information loss for each OD pair, and the other one is the maximum OD demand flow information loss for observed link. And by observed link, I mean the links in a road network which are equipped with traffic sensors. This is a flowchart of my study. As you can look at the inputs include observed link flows, road networks topology, and prior OD demands, and we try to rely on the least amount of information for this framework. The framework starts with a sensor assignment, and there is a back and forth in OD demand estimation and stochastic using of equilibrium. And I use this approach as I assume the link choice proportion between OD demands is not a fixed value. After finding the resulting OD demand, we can calculate the OD demand flow information loss on observed links and for each OD pairs. And if we meet the optimal GA criteria or termination criteria in the proposed GA, then we can reach the optimal sensor location. This is a part of result which is proposed for a toy example called Fishbone network, which is constitutes of 18 links and 10 nodes. And in this work, we assume there are 4 ODs between the origin and destination nodes. In this figure, as you can see, as the number of sensors increases from 2 to 8, the average of the maximum OD demand flow information loss decreases. In another part of the study, I try to focus on the deployment of more advanced sensors. And as we can see in this table, by applying more advanced sensors, although it needs more budget for their deployment, the aggregated maximum OD demand flow information loss on OD pairs decreases. In another part, we showed that there might be a situation that the maximum OD demand flow information loss on OD pairs results in equal values, but if we focus on observed link, they might result in different values, and that shows the importance of introducing two factors for sensor deployment. And also here we showed that if the failure rate is a function of time, as the value of time increases in a horizontal axis, the maximum OD demand flow information loss increases correspondingly as well. To show the efficiency of the proposed GA, we implemented the model for Sioux Falls network, and we assumed there are 30 OD pairs in this network. And as you can see, the model can rapidly converge to a local optimal value. In summary, I mentioned three main bullets as the findings of this work. Both objective functions that were used to determine the sensor assignment is important to find a robust sensor location sets. Also, we demonstrate that the positive effect of budget growth under reduction of aggregated maximum OD demand flow information loss. And in a comparison work, also we present two different layouts in the Fishbone network that equally minimize the effect of sensor failure on link flow observability. But also we showed for these two layouts, there are different levels of OD demand flow information loss for OD pairs in this network. Thank you so much for your attention, and I'm open to your question. Have a good day.